Want to grow your own beautiful crystals at home? Let's make borax crystals in just a few easy steps. You'll need borax, hot water, a jar, a pipe cleaner, and a string. Dissolve 3 tablespoons of borax in 1 gallon of hot water. Stir until completely dissolved. Dip pipe cleaner into the solution, let it hang in the jar overnight. Shape your pipe cleaner, tie it to a string, and let it sit overnight in the solution. And look! Your sparkling borax crystals are ready. Try this fun science experiment and tell us how it went. Like, share and subscribe for more amazing chemistry tricks. Meet cesium, one of the most reactive metals on Earth. This soft, silvery gold metal is so reactive it must be stored in special containers to prevent it from exploding on contact with air or water. Cesium sits at the bottom of Group 1, the alkali metals, making it the most reactive of them all. Drop cesium in water, and boom! It reacts instantly, releasing hydrogen gas and enough heat to ignite an explosion. But it's not just destructive, cesium is also used in atomic clocks, keeping time so precisely that they only lose a second every 100 million years. Cesium is vital for GPS, space technology, and even medical research. Explosive, yet essential, cesium is truly a metal like no other. Subscribe for more amazing chemistry content.
Meet Mercury, the only metal that's liquid at room temperature. It's dense, shiny, and full of surprises. Mercury is so dense that even a bag of metal pellets can float on its surface. But don't be fooled, mercury is toxic. While it's safe to touch briefly if you don't have cuts on your hands, always handle it with caution. Fascinating, right? Mercury is a true marvel of chemistry, but always respect its dangerous side. Science is amazing, and safe handling is key.
How to grow your own crystal. Can you believe these sparkling crystals? You grow it all in a cup. Anyone with salt at home can try it. First put the salt in the cup, then pour in hot water and continue to add salt until the salt can no longer be dissolved. What we have here is a saturated solution of salt. Then strain out excess salt and impurities while they are still hot. Leave the lid on the cup for a few days with the temperature and evaporation of water. Salt that does not dissolve in water is sucked out, crystallize, gather at the bottom of the cup. That's when we open the cup. Choose a crystal that pleases you, as seed tied with string. Tie the other end to a pencil or cardboard. Then it's immersed again in a saturated solution. As time goes by, continuous evaporation. The solution is getting stronger and stronger. Insoluble crystals either sink to the bottom of the glass or fused with our crystal seeds. So the crystals are going to get bigger and bigger, to make it bigger. You have to keep making new saturated solutions for it to absorb. It can be taken out at a certain point. Try not to touch the crystal with your hands at this time. Need to dry with a cloth first. Then paint the crystal with a colorless nail polish. I can hold it in my hands and play with it. We can also use materials such as copper iodide, sulfate. Make crystals of different colors. Looking at the brilliant gems you've made, isn't it very satisfying?
Ever wondered how to turn glass into a silver mirror? Let's do the famous silver mirror test. First, add silver nitrate solution to this flask. Now add sodium hydroxide. Watch closely. A brown precipitate forms. The silver mirror test is a classic chemical reaction used to detect the presence of aldehydes. It relies on Tollens reagent, which reacts with aldehydes to form a metallic silver mirror on the glass surface. Next, add ammonia drop by drop until the brown precipitate disappears. Now we have Tollens reagent. Time to heat it up for a few minutes. Now let's add dextrose and give it a shake. Watch this. The dextrose reduces silver ions into pure silver, coating the inside of the flask. And just like that, we made a silver mirror. Science is amazing. Like and subscribe for more cool chemistry.
What happens when sulfuric acid meets paranitroaniline? A rapid polymerization reaction creates an expanding, foam-like structure. This lightweight, heat-resistant polymer was studied by NASA for advanced fireproofing materials. A breakthrough in safety born from chemistry. Want more amazing chemistry reactions? Subscribe now.
Helium floating so high, lithium, beryllium, metal in the sky. Boron, carbon, life's in the zone. Nitrogen, oxygen, breathe alone. Fluoride, neon, bright like the sun. Sodium, magnesium reactions are fun. Boom, bang, let's react. Periodic table.